Hello students, I wanted to show you our synthesis project and give you clear instructions on what your job is with regard to it. You'll notice, for example, on our syllabus that there is a synthesis assignment due on the 28th. What is that synthesis assignment? I will show you exactly what it is and how you accomplish it. First of all, as we look through our more refined voting records, I initially posted an announcement saying that I did not want us to tackle Cudraflavone C because it's structurally very complicated, much more so, at least at surface level, than the antifungal polyketide here or calcinoid B. However, as I looked more closely at antifungal polyketide shown here and calcinoid B, I discovered that synthesizing these two molecules, or either of these two, is much more complex than I originally thought. Sorry about that. So I actually would like us to focus on Cudraflavone C, and it turns out that Cudraflavone C is the one that got the most votes prior to me executively eliminating it from the candidacy. So I'm reintroducing it, and that is the one that we're going to be doing. So for your synthesis project, your job is to design a total synthesis of Cudraflavone C, shown right here. Now, just so you know, even with the modest amount of organic chemistry education you've received so far this year, you can still, using this very powerful database called SciFinder, design a total synthesis of Cudraflavone C, as well as any other molecule, pretty successfully. I'll show you how. We begin here by navigating down to the USU Library webpage, accessible at this HTML shown up here at the top of my screen. You scroll down here and go to Articles and Databases. So click that, and then we scroll down here and go down to under Science, where it says Chemistry and Biochemistry, and then you scroll down here to SciFinder. Now it's possible, I'm not 100% sure, but it's possible that you may need to be on a USU networked computer in order for this to work your initial time. Also, for the first time that you do, you'll need to register or set up your account. So you click set up your account here and set it all up using your Aggie name or user number and password, or USU name and password. Your A number and password, that's what I'm trying to say. We click SciFinder right here, and then it will take us to the USU portal where we log in. And if you're already logged in on USU Network, then you can bypass that. And then you just type in your username and password that you've set up in that registration. Along the way, it might take you to a page that asks if you want to use Classic SciFinder or some newfangled SciFinder. I recommend using Classic. The new one is really messed up. So what we're going to do next is we're going to draw in a structure that looks like Cudraflavone C by clicking here at Chemical Structure, okay? You click right here to on the section that says Click to Edit, and it'll bring up something that looks kind of like Microsoft Paint, except it has a bunch of chemical tools. So I'm going to jump back and forth and make sure that I draw this, matching it correctly. So I've got a benzene ring or aromatic ring there, and then I've got a six-membered ring here, so I can kind of fuse that right there. And then this six-membered ring has a branch point off there with another aromatic ring there. And then I've got double bond to oxygen down there. I will identify or change all of the elements where they need to be later on. I need to have an oxygen coming off of this position, and then another one at this position right up here. And then as I go down here, I need an oxygen up here and then here. So yeah, we'll go ahead and change all of these elements to oxygen by clicking the oxygen tool down here. And we go O, 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 O. And one thing I also noticed that I neglected to do is have a double bond at that position. So I'm going to just grab my carbon tool here and put a double bond here. Now you'll notice that there are a couple of differences between what I've just drawn on the screen and what our original structure is of Cudraflavone C. For example, Cudraflavone C has H's on the end of each of these oxygens, and it has this alkene appendage coming off of this location as well as this location down here. You see that okay? What I'm going to do is I'm not going to draw those. The reason is because this is a brand new or relatively new, recently reported natural product, which means there will be no total synthesis of it published anywhere. So if you draw in your exact molecule and try to use SciFinder, it's going to be too narrow of a search to be able to find or help you. So what I try to do is draw something that's close, but not exactly the same, and see if I can navigate it that way. Now, if it ends up still not working, then I will try to make it even more generic. For example, remove some of the atoms, or remove a double bond here or there, and see if I can make it more generic, and then try a search there. Over here in this field, I'm going to select substructure search as opposed to exact search or similarity search, and then click OK. It takes me to this point. I still have it on substructure, and then I will click search right here. whereupon it will take me to the results page. Now you'll notice as you scroll down here, there's actually 1,642 results. So there are quite a few, but it sorts them in order of relevance. So the structure that's closest to the one that I drew is shown up here. So what I'm going to do is I'm going to mouse over this structure, and I guess I'll zoom in on a little bit so you can see it more clearly. You mouse onto it, and then there's a little chevron double arrow symbol. You click that and then select synthesize this. Okay, now what it's going to do is find any reported syntheses of this molecule. Now, unfortunately, sometimes when you do this, it shows some results that are less valuable or helpful than others. One of these has a very poor yield, and this one probably is going to have a poor yield. But what I tried to do here is scroll down and maybe refine it according to number of steps. So I'm going to click number of steps here. I click refine over here, click 1, and then click refine. The reason is because this will narrow my results to only show one-step reactions as opposed to multi-step sequences, because I want to dissect this one step at a time. This is an interesting reaction right here. It has a link here to the article where it's found in Biotechnology Journal, this volume number, page number, and source number. What I'm going to do right here, because this reaction looks kind of good, and you can see that the only difference between the starting material, which looks kind of complicated, and the target molecule is that the starting material has a bunch of benzyl groups attached to its oxygens over here. So this is a tetrabenzyl protected starting material, and this step is just removing the benzyl groups to unveil the unprotected OHs. Nevertheless, what I'm going to do is I'm going to click this, and then I'm going to go up here and click Send to SciPlanner. I'll show you what that does in just a moment. Now, obviously, this molecule right here is complicated, and we can't just buy that molecule and then do a one-step synthesis, so I'm going to have to go backwards even further. So I'm going to go up here, mouse over this one, click this arrow, and then select Synthesize This, and then it's going to show how this molecule can be made. I think we're all going to be focusing on this particular reference, because it seems like all of this work is coming from this reference. This shows a two-step process that begins from these two starting materials. So evidently over 2 steps, this research group ran or combined these 2 molecules to make this one. Okay, so what I'm going to do is click this, and I'm going to select Send to SciPlanner. And again, you can scroll down the results and see if there are any that look maybe a little bit better. In any event, obviously, these 2 molecules are a little bit complicated as well, and they're different molecules. So I'm going to have to click here and select Synthesize This. And I'm going to continue going backwards until I can find a molecule that is commercially available and relatively structurally simple. So this one you can tell is commercially available because it has this Erlenmeyer flask that's orange, and it's got a little tag on it indicating that you can buy it. Now, I realize that this product that we're trying to get in a poor 20% yield is also commercially available. However, it only has 70 commercial suppliers, and I suspect strongly, just from my experience, that when we see this, that the commercial sources are going to be very expensive. This molecule, however, looks structurally simple enough that I suspect we can probably tackle this okay. All right? You'll see that the reaction itself is relatively simple. So I'm going to take this, and I'm going to go Send to SciPlanner. Okay? And then what we've got then is a simple one-step reaction that forms this molecule. The yield is quite poor, it's 20%, but once we have this molecule on hand, we'll go backwards to where we were, and you'll notice that that molecule I was just pointing at is this leftmost molecule that can be combined with this molecule under this 2-step sequence to eventually arrive at this final product. Now, what do we do about this molecule? Well, that's kind of complicated, so we're going to select Synthesize This, okay? And see our results. Hopefully the results are helpful. Yeah, you can see that this molecule is much easier and higher yielding to attempt to get, and it does have quite a number of commercial suppliers. But what we're going to do is we're going to, and this starting material right here you can see has a lot of commercial suppliers, so we're going to select this reaction and select Send to SciPlanner, okay? Now, I think we've gone backwards far enough in our synthesis to get to some relatively simple molecules. Now, I realize with your knowledge of electrophilic aromatic substitutions, you might be devising in your mind's way of synthesizing this molecule as well as the other aromatic we were looking at a moment ago. However, that's not necessary because they're commercially available from lots of sources, and I suspect that probably some of those sources are going to be relatively inexpensive enough for us to be able to purchase and use. What we're going to do now is we're going to scroll up here and select this tab, SciPlanner, where it will show all of the reactions that we just grabbed. I'm going to go ahead and go to new, up here to workspace and select new, so it clears off what I had there before from some previous work. And then I'm going to drag all of our reactions one at a time over here. I'm going to start with our final reaction. Okay, you see that? That's the reaction that will get us to the flavone C molecule that we're trying to make. And then I will grab this reaction right here. And what you'll notice is that this reaction, oh dear, I scrolled a little bit too far. This reaction's product is exactly the same as the product shown here, okay? So what you can do is you can drag this and lay it on top of that molecule, and then it will merge them. You see what I'm saying? So what we're doing is we're doing a synthesis to eventually get to our target. Now, how do we synthesize each of these? Well, we have those in our reaction lineup, so I'm going to pull these reactions over here. I'll grab this one right there, and then I will grab this one right here. Okay, now I realize this is getting kind of small. I'll sort of pull this up here. Oh, good grief. One thing that is kind of obnoxious about SciFinder is the scrolling issue here. So I'm going to kind of scroll down here and hopefully, okay. So you can see that this molecule is exactly the same as that molecule. So I'll lay the one on top of the other, and then I will grab this, and then I'm going to go right here, and I'm going to grab this one and lay it on top of that. You see that? All right, so what we have here is a total synthesis that begins with some relatively simple building blocks that are all commercially available, indicated by the little orange-colored Erlenmeyer flask, okay? And each of the reaction conditions for each of these steps is accessible. If you mouse over the number and click that, it will show you what the reaction conditions are. And all of them seem to be relatively simple. I'm going to select them and move them a little bit so I can get them centered on screen. I can go up here to workspace and then select export. We'll go ahead and change the name to synthesis and then select export. Now, one thing you'll notice with all these check boxes is that I have reaction details, substance details, and reference details all there. So I'm going to select export right here. I will choose the file where I want to insert it and then wait a few moments for it to generate the PDF. I open up that PDF and scroll down, and what you'll see is a detailed breakdown in this document of every single reaction, all numbered with the conditions required and the reference to the peer-reviewed article. You'll notice that reactions 1, 2, and 3 up here all come from one article, and then reactions 4 and 5 come from another. So this is kind of the way you tackle one of these, and you can hopefully see that it's very straightforward, very user-friendly, and very cool. What we do next is we can then, after we look more closely at these references, look up the very specific procedures and reagents that we need to order, and then we can go about ordering them so that we can carry this out. And that's what we'll plan on doing during the last segment of, or the last 4 weeks of the semester, okay? So for your synthesis assignment, your job is to design your own synthesis, and you might vary it a little from the one that I just showed you of our Kudra-Flavone C. Okay? You'll notice a major difference between my synthesis and Kudra-Flavone C is that the synthesis that I showed up here does not have, if I zoom in here, the two alkene appendages at this location and at that location. So you might have to go backwards and ask, how would I get those on there? Well, I would have to have one alkene appendage installed at this location, and then I work backwards from there. And then if I work backwards and trying to figure out where that carbon atom is over here in this starting material, and then go backwards and trace it back to where it would have to be up here, okay? So again, what I want you to do is accomplish that, figure out where you would need to install those carbon appendages on your original starting materials, and if necessary, go back even further to make sure that you have those starting or syntheses or synthetic route here on SciPlanner for these. Then you can generate the PDF, and then you can email it to me, and that is your synthesis assignment. It will be due on the 28th of February, and hopefully you can see it's not quite as horrifyingly difficult as you might think. Hopefully that'll make sense. Email me if you have any questions, and please have a wonderful rest of your day.